In today's session, let us see exception handling, introduction to exception handling. So before understanding what is exception handling, first of all, you need to understand what is an exception. What is an exception? It is an abnormal condition that arises in a code at runtime. So what do you mean by runtime? You know what is compile time and runtime as far as Java programming is concerned, right? So when you make errors in your program, those errors can be Those errors can be basically of two types. One is syntactical errors, and the second one is logical errors. So, in your program, any programmer will make mistakes or errors in the program while writing the program. But we can categorize these errors that we make in writing the programs into two fundamental categories called syntactical errors or simply syntax errors. Okay, syntactical or syntax errors. So you can also use the term syntax simply. And the second one is logical errors. Generally, in Java programming, these syntax errors will be identified uh, during compilation. So when you compile the program, these errors will be identified by your Java compiler. But coming to these logical errors, they cannot be identified during compilation. They can be identified during runtime. So that means what? When you compile your program by using the command java c file name dot java, whatever errors you get, if at all, if there are any errors in your program, those errors are nothing but syntax errors. And when you run the program, sometimes when you run the program, also you'll get an error. Those errors are logical errors actually. Means what? Y- Your program will not have any syntax errors if it is successfully compiled. So what do you mean by syntax errors? Syntax errors are nothing but the rules and regulations that we are supposed to follow when you write a program. Every programming language will have those syntax. Wait a minute. So generally, what are syntax errors mean? Uh, every programming language will have some rules that we need to follow. For example, if you take any C program or Java program, the syntax is identical, almost similar in C and Java, right? Every statement in your program must end with a semicolon, right? And we use some keywords, and keywords are in small letters. We cannot use capital letters. And similarly, keywords cannot be used as names of variables or functions or methods, classes, objects, etc. Right? So these are some of the examples of rules that we need to follow. Semantics, we call them as syntax and semantics. So when you don't follow the syntax and semantics, because your compiler is a software which contains all these syntax and semantics. When you compile your program, what the compiler does is it will check whether the program is written by following the syntax and semantics or not. And anywhere in your program, in any line, if your syntax and semantics are not followed, then immediately the compiler will generate an error wherever in whichever line the rule is violated, semantics and syntax are violated. In that particular line, it will identify what is the mistake you made, what is the error you made, and all. It will show you. It will describe you that error about that error, so that you can edit the program and correct those errors and then compile it again. So in that way, after successfully completing the program with by following completely the syntax and semantics without any violations, then after that your compiler, what it does is it will compile the program and generate the .bash file, right? So these errors are identified during compilation. So such errors are called as syntax errors and semantic errors or syntactical errors. We have already noticed or we have seen so many errors when we were writing programs and we have corrected them. So all those errors are related to the syntax programming language rules. So just like natural languages will have some rules in framing sentences, right? So in the same way, every programming language also will have some semantics and syntaxes, and we need to follow that. So if we don't follow, the errors that are generated because of violating those rules and regulations are said to be syntax errors. And coming to the logical errors, these errors will be in terms of the logic that you construct. Example, you are writing a logic for finding the factorial of a number. If the logic is constructed badly, then your program will generate some errors, some exceptions, due to which your program will not work properly. First of all, you will not get the desired output, and sometimes your program will be terminated abnormally. Terminated abnormally means without completely executing the program. Say if there are some 10 lines in your program, after executing say 5 lines, you have made at line number 5 you have made some logical error, some kind of error, due to which what will happen is the program will be terminated, and the rest of the 5 lines in the program will not be executed, right? So these types of errors, we can call them as logical errors. These are identified during runtime, they are not identified during compilation, because the compiler will not check whether the logic you have written is correct or not. So when you compile a program successfully, it doesn't mean that your program is correct. Your program is correct syntactically, but you may not get the output properly because your logic is not correct, right? So if your logic is not correct, your logic will not be identified with any mistakes during compilation. So during compilation, we will not come across any such logical errors. So we'll come across only when you run the program. That is when you run the program using command Java file name, right? So when such runtime error occurs, or when such we can use the term exception also for this runtime error. Uh, so when such exception occurs, what will happen? Your program is abnormally terminated. Normally terminated means what? After executing all the statements in your program, if your program will terminate by giving you the desired output, whatever output you are expecting, that kind of output you will get, and then the program will successfully terminate. But what is abnormal termination means, without giving you the proper output, without completely executing all the statements in your program, in the middle itself, in the middle of the program execution itself, the program will be terminated abnormally. So that is called as abnormal termination, which is not normal. Normal termination is successful termination by giving you the desired output. Abnormal termination is nothing but which is not normal. That means you will not get the proper output, and you will not get the and the program will not be executed completely. It may be executed only partially, right? So these kind of error conditions that occur during runtime, we call them as exceptions in Java programming. Okay, in Java programming, we call it as an exception. So if you look at this presentation, exception handling presentation, we are defining an exception. This first point here, if you can observe. So what is it saying? An exception is an abnormal condition that arises in your code sequence at runtime. A code sequence means a set of statements that are there in your code or program, right? So when they occur at runtime. So what is that error? It is an abnormal condition. That means there is some mistake in your logic of your program, due to which the program will be terminated, right? So a Java exception is an object that describes an exceptional condition that has occurred in a piece of code. So coming to Java, how this exception is represented by your Java runtime system means it is represented by using an object. So you know what is an object in Java? An object is an instance of a class. Okay, so as such, everything is represented as an object in Java programming. Even in multi-threading, also you have seen Threads are also represented using objects of a predefined class called thread. So even exception handling is also uh, going to do what is it is going to represent an exception that is occurred in your program as an object. Then what type of object it will be, which class object it will be, that we need to know. So for that we have many predefined classes, not just one predefined class, but there are many predefined classes. For every type of exception that occurs in your program, uh, there is a separate class representing that type of exception. Then whenever such a type of exception occurs in your program, automatically an object of that class will be automatically created in the program. Right? For example, a division by zero exception. So division by zero exception means what? You're performing a division operation in a particular line of code in your program. Say it is like this: A is equal to B modulo divided by C, like this. So unfortunately, if the value of C happens to be zero, because C is in denominator position, and if it happens to be zero, then what will happen? Division by zero in mathematics it leads to a value called infinity. But computer science does not define a value called infinity. In computer science or in any digital device, we can only represent finite values. We cannot represent infinite value. So, because you're a electronics student, you must know about this representation of values in digital devices. You have a subject called digital logic design, right? So we can represent zeros and ones. Using zeros and ones, you can represent any number, but not which is infinite. You can only represent up to an infinite number, and your memory will not. You cannot create a memory hardware memory device which can hold an infinite value, right? So that's why in computer science engineering there is no infinity value defined. So whenever you try to divide any number with zero, an exception will be occurred, and this exception will be represented by a class called arithmetic exception, right? So there is a predefined class called arithmetic exception which is defined in Java. This will be automatically imported. You need not do anything in your program exclusively. Just like for multi-threading, how thread class will be automatically imported from lang package. Even this arithmetic exception class also will be the same, right? Why the name is arithmetic exception means because division operation is an arithmetic operation. So when you're performing an arithmetic operation, if an exception is occurred, we call it as a arithmetic exception, right? Similarly, there are many other exceptions. There is another exception called class not found exception. So this exception will occur when you're trying to create an object in your program for a class which does not exist. Say, for example, you're trying to create an object for a class called A, like this, right? This is an object creation in Java. So what is the name of the class here in this example? Name of the class is A. So in order to create this object in your program, first of all, you need to define this class somewhere, right? After defining that class, then only you can create an object for that class. Without creating a class, how can you create an object for that class? It will not be possible, right? So that's why when you try to create an object like this, an exception will be generated in your program, and that exception is nothing but class not found exception, right? Similarly, when you're creating an error, when you're using errors, and if you have declared the size of an array to be say 10, so the indexing will be from 0 to 9, and you're trying to access an index which is beyond 10. That means say you're using index 11, 12, 13 like this, then what will happen? There is no such index in your array because you created an array with size 10, and by default the index will start from 0 and end at 9. Even 10 index also will not be there for that array, right? So in that case, an exception will be occurred. That exception is nothing but array index out of bounds exception. The name of the class is array index out of bounds. Right? So these are all predefined classes. These are all predefined classes. Right? So when any of such exception occurs in your program during runtime, automatically what will happen is an object of this particular class representing that exception will be automatically created. You need not create anything in your program, right? So it will be automatically created. And what is that object going to contain? That object going to is going to contain a description about what exactly happened in your program due to which your program has been abnormally terminated, right? So when you take C programming does not have this concept of exception handling. That's why what will happen when you compile and run your C program, and if you make any syntax logical error in your C program during runtime, your compiler will not even display any description about what has happened in your program exactly. Abnormally, the program will be terminated, and the user will not be able to understand why the program has been abnormally terminated. He himself has to go through the entire program and identify uh, where he has made a mistake. If it is a division by zero, we can easily identify. But if something else, a complex logic is made, is constructed, and which contains a small error in that, you will not be able to identify that complex error, right? So it is a difficult task to handle those runtime errors that occur in your C program. But coming to Java, Java is not like that. There is an exception handling mechanism in Java, and you can handle the exceptions that occur during runtime in two ways. You may handle it for yourself, or you can leave it for the Java runtime system. You don't handle, Java runtime system will handle it. If you handle, Java runtime system will sit idle, and your program code that you have written will handle automatically that exception that occurs in your program, right? There are two ways in which you can handle those exceptions. One way is to you yourself can handle the exception in your program by writing the code for it, and the second way is you can leave it for the Java runtime system. Java runtime system will handle that exception, and it will display the message to you when you run the program about the description about that exception. Okay? So till now we didn't use this exception handling mechanism in our program. So that's why even then we were able to run the program, and if any exception has occurred in our program, that was automatically handled by Java runtime system. Okay. So that is the reason why your program has not been terminated abnormally, and there is a message for you even though if it is terminated. There is a message for you, exact mentioning what or describing what is happened in your program, and due to which your program has been terminated. This thing will not happen in C language. It will happen in Java only because Java uses a concept called exception handling for handling such situations. Okay, so let me show you with an example program, uh, both the ways. That means we'll not handle that exception in our program. We'll leave it to the Java runtime system. I'll take simple exception. I'll not go to the complex thing because this is simply an introduction to exception handling. And again, later we'll discuss this exception handling concept in a broad manner, in a in-depth manner, by going through uh, many things that we have in Java exception handling concept. But before that, I need to tell you about some keywords that we need to use in our program. So if you are able to observe in this slide, uh, some words or keywords are mentioned here, which are mentioned in bold letters. You can see there are five keywords here. First one is try, second one is catch, third one is throw, fourth one is throws, and fifth one is finally. So you have totally how many keywords to handle exception handling in Java? So these are the five keywords: try, catch, throw, throws, and finally. But among these five keywords, uh, try is a block. That means a brace will be opened after the try keyword and the brace will be closed at the end. And in between these braces, you can write a piece of code, right? Similarly, a catch is also a block. Throw and throws are simply keywords, and finally is again a block. So, what is this try block means? Uh, whichever piece of code you will be suspecting that it is going to generate some kind of exception in your program. It may generate an arithmetic exception or a class not found exception or any other type of exception. There are many exceptions defined in Java. We have many classes representing each of those exceptions. We'll see that list later. But as of now, I mentioned some few of them, three of the exception classes. One of them is arithmetic exception class, right? And you also need to remember once again the Java's naming convention. You observe the name of the class is arithmetic exception. It is a predefined class, right? So because the name contains two words, the first word is arithmetic and second word is exception. What is the naming convention followed for classes? Each word will begin with a capital letter. How many words are there? That many words. Each of them will be beginning with a capital letter. So that's why in arithmetic A is capital and exception also E is capital. Similarly, if you look at the next class, the name of the class is class not found exception. There are four words here. First one is class, second one is not, third one is found, fourth one is exception. So if you observe, all the four words are beginning with capital letters. C capital, N capital, F capital, and E capital. And every class name will end with this word exception, right? And the first word or the previous words that are there before the exception word will be the name of that exception. Okay. Then coming to the third one also, array index out of bounds exception. How many words are there? One, two, three, four, five, six words are there. Array is one word, index is second word, out is third word, off is fourth word, bounds is fifth word, exception is sixth word. So if you observe, all these six words are beginning with capital letter. A, I, O, again O, B, E, right? So in that way, the naming convention is strictly followed for all the predefined classes, interfaces, and methods. Even we don't follow for user-defined classes and objects that we create, but Java will follow the naming convention strictly for all the predefined classes and interfaces and methods, even packages also. All the packages will be in small letters only. Class names and interface names will have, if they have multiple words, each of the word will begin with capital letter, and if there is only word also, one word also, that word will begin with capital letter. If it is method, the first word will be in small letters and the remaining words will begin with capital letter. If there is only one word, then all the letters in that word will be small letters. Even the name of variables also, if there are multiple words in that name, the same convention is followed as that of the methods. The first word will be in small letters and the remaining words will begin with capital letters. Right? So that you need to notice here even in this exception handling predefined classes also. Right? So what you're going to do in try block, coming back to our try block, what is written inside the try block means any piece of code in your program which is part of your complete program, which you feel that or which you suspect that this is going to generate some kind of an exception, then what you need to do is you need to put that piece of code, one or two lines or how many lines, whatever it is, that you need to put that in the try block. And if an exception occurs, automatically an object for that class, just before we discussed, right? Whenever an exception occurs in your program, automatically an object of that particular class will be created. So when you write that a code which is going to generate exception inside the try block, automatically a keyword, an object will be created for that particular class representing that exception, and that will be thrown. And if it is thrown, this catch block will hold that exception. So this catch block will just look like a method. It will have a parameter, and the parameter is nothing but the name of the class, which is representing the type of the object that is created in the try block. Means if an arithmetic exception is occurred in the try block, for example, then we need to write the predefined class name representing that arithmetic exception like this here, and give a space and mention that object name. What you can give any name. Automatically an instance will be created, and that instance will be thrown to this catch block, and the class block within the parenthesis you mention some name here for that object. That object will store that instance. So now this object E, or I'll give it as AE, arithmetic exception, will be representing the description about what the exception that has occurred in your program. And if you use this to print system.out.println, then automatically uh, that object will describe in the form of a string what has happened in your program and why your program has been uh, not working properly, what exception has occurred, right? So this is how you can use try and catch block. Throw keyword is used to create an exception automatically without the need of writing the code which will generate an exception. Instead of doing that way, if you want to create an arithmetic exception object simply without performing any arithmetic operation, you just want to create an arithmetic exception, then use the throw keyword and then mention the new keyword here, just like you create an object for an ordinary class, right? After the assignment operator, whatever part you will have, the new keyword and the name of the class. Say, for example, it is arithmetic exception. Then you mention here the constructor for that arithmetic exception here. So then what will happen? This will automatically create an arithmetic exception object, even though you didn't write any code that is creating arithmetic exception. This throw keyword will create an arithmetic exception and throw that arithmetic exception object. So you can write this statement uh, instead of writing it, you can put this in a try block. Then this catch block will handle it. Right? So there are two ways. Instead of doing this way, you'll write the code, say A is equal to B divided by C, like this statement. And for example, you have assigned C is equal to some 0. Here A is equal to, sorry, B is equal to say some 5. Like this, you have assigned two values for B and C respectively, and then you are trying to perform division operation like this, B divided by C. And this line will generate an exception. So in this line, what will happen is an arithmetic exception object will be created, and that will be automatically thrown to this catch block. So this is how normally if you write a code, an exception will be generated, and that automatically an object will be created. So instead of doing this way, you can also do the other way by using the throw keyword like this, right? So that is the purpose of the throw keyword. And throws keyword is used to mention for a method. You'll be definitely writing the code in some or the other method, in the main method or any other method. And if that method in which that you're writing the code which is going to generate some exception, and if that exception is not handled in that method by using some try catch mechanism, then method will write beside that method definition using the throws keyword that this method is going to generate or it is capable of generating this kind of exception. It is the responsibility of the caller, whichever method is going to call this method. That method has to take the responsibility of the handling that exception, and this method is not going to handle that exception. So that is the meaning of throws keyword. Anyhow, we'll not use it now as of now. We'll discuss it later in detail about throws keyword. After writing some programs using simply try and catch, then you'll understand about throws. And finally, block. Uh, for example, when an exception occurs in your program, what will happen is, say in the try block, uh, So your intention is to find the quotient after dividing B with C. Store the result in A and then display the value of A using a system.out.println like this, for example, right? Then before that system.out.println, here you will get an exception, right? So when an exception occurs here, automatically an object will be created and that object will be thrown to this cache block and the system.out.println in the cache block will be executed. It will never return back to this place after this statement is executed. First, this statement gets executed, then after that, second one, then this third one. And from here, after the third statement, because in the third statement an exception has occurred, the control will come to this cache block and this system.out.println statement will be executed. So when this will happen, when an exception occurs here, if that exception does not occur here, for example, instead of 0, if it is say 2, then what will happen? An exception will not occur. A division by 0 or arithmetic exception will not occur. So because exception did not occur, the system.out.println will be executed and it will display the value of A, the resulting value of A. Right? But unfortunately, if an exception occurs because this value is 0, then this statement will be skipped. That means what? After an exception occurs in your program, the rest of the lines which are there after the line in which an exception occurred within the try block, within the try block will not be executed. That means the program will be terminated. Uh, but it will continue with the rest of the statements which are there after the catch block, which are there at the catch block. Okay? So if you want, if you are doing some important task in the later lines in your try block, somewhere after system.out.println, you are trying to do some important work. You have opened a resource, say a file or a database connection or something. And because the statements which are there after the third statement will not be executed if an exception occurs, then the database connection that you opened it earlier will not be closed and it will be vulnerable for attacks. So it will not be secured. Your database connection will not be secured. So in such case, what we can do is we can write that closing of database connection code here in this finally block. What is the importance of this finally block means? If an exception occurs, even if an exception occurs or it does not occur, it doesn't matter for this finally block. Definitely, the statements that you write inside this finally block will be executed. Then only the program will be terminated. Even though an exception occurs, the finally block will be executed. Even if exception does not occur, also the finally block will be executed. In both the cases, the finally block will be executed. So you'll understand about this finally block also when we start writing the programs on all these concepts. As of now, you need to understand the fundamental concept of exception handling. Exception handling is a mechanism using which you can handle exceptions in Java. Right. So now let me write a small program and show it for you. First, we are not going to handle that exception in our program. We are directly going to leave that handling mechanism to the Java runtime system first and see what will happen, right? And then we are going to handle it in our program. We are using the try catch mechanism. Okay. So let me show you by writing a small program. So for our convenience to understand this concept, I'm not going to use multiple classes. I'm going to use only one class. I'm going to create a new folder, exception handling, exception. So here I'm going to save my program, exdemo.java. Okay, so simple program, only the main method defined in this class. The program has been successfully compiled because we didn't make any syntax errors here. We have followed all the syntax. So we have used the class keyword, which is in small letters. Then we have given a name for the class, open the brace, close the brace at the end, and we have defined the main method. The keywords are given in small letter. Public is a keyword, static is a keyword, void is a keyword. So all the keywords are mentioned in small letters. Wherever space is required, that is given here between public and static, between static and void, between void and main. And main is the name of the method, and opened and closed parenthesis, and between that, main method as we know receives one command line argument of type string, which is an array of strings. Then we have created two integer variables a and b. Uh, for that, we need to use the keyword in. So keywords are in small letters, so we have used them. After that, giving a variable name, giving a space, a is 10, comma b is 0, ending with a semicolon. So every line is ending with a semicolon. We observe. So we didn't make any syntax errors. We have followed all the rules and regulations of Java programming language and written the program. So that's why you will not get any error when you compile the program. But now when we run the program, let us see what will happen. See what is that you're getting here? Exception in thread main. So why this thread main? Because whenever your program starts executing, automatically one thread starts executing. That is called as a main thread. We have discussed it earlier, right? So in that main thread, you're getting an exception. And what is that exception type? Java.lang.arithmetic exception. So arithmetic exception is the name of the class. It is the name of the class. And where is it defined? In a package called lang, java.lang. So it is displaying, it is describing that exception as an object of type which class? Arithmetic exception class. And after that, you're given a colon symbol, and followed by that brief description about what exactly happened in your program. So what is that happened? Division by 0. And where it has occurred, in a file name called exdemo. In that you have a method called main method. So the file is saved as like this, exdemo.java at line number 6. Right? The error has occurred at line number 6. So let us go to the program and check. So what is the line number for this line? It is 6, right? You are able to see at the bottom line number 6. So an exception has occurred in this line in a file name saved as exdemo. In that we have a class called exdemo, and the class contains a method called main. And in that main method, line number 6, right? So in class called exdemo dot separated by the name of the main method. So this exdemo is the name of the class. Dot in that class, what is the method name? Main, right? So in that main method, and this main method and exdemo class, where they are located? In a file called exdemo.java. What is the line number in which the error has occurred? That is 6. So who is saying this one? We are not handling this exception ourselves. So who is handling this exception? Java runtime system is handling this exception, right? So the Java runtime system is handling this exception and informing the user about this exception. And if you can observe, because an exception has occurred here, after this statement, whatever statements are there, the system.out.println, this is not executed. will not be executed because this line is after the line in which the exception has occurred. So what is the line in which exception has occurred? This one. So whatever lines of statements you have written after this statement in which the exception occurred, the rest of the lines after it will not be executed. No matter how many lines of code you write after this, everything will not be executed. We have written only one line here, but even if you write 100 lines also, that will not be executed. Only up to here, your program gets executed. You write anything here, for example, so you're able to see you're getting the hello message displayed by the first system.out.println. But after that, in this line, an exception has occurred. So the next last system.out.println, this is not being executed. Right now, how to handle this exception in our program ourselves without leaving it to the Java runtime system? How to handle ourselves? So, as per our earlier discussions, what we need to do, any piece of code in your entire program, which you are suspecting it to generate an exception, we have to put that piece of code inside a try block, right? So, I'm suspecting this piece of code, which is written here, that is int c is equal to a by b, and the next line system.out.println, both lines to generate an exception. So I'll put this inside the try block like this. So immediately after try block, there must be a following catch block. So if you don't define a catch block immediately followed by the try block, there should not be. Remember one important point: for every try block, this is a try block. It is starting here and ending here. Immediately after the try block terminates, there must be a catch block. There should not be any other statements between this try block and catch block like this. So after the brace is closed for try block, you cannot write any other statements here. You cannot write a system.out.println or anything like this. If you write anything in between these two blocks, you'll get an error. Compilation error will be generated. So always there should not be anything between this try and catch block. And because I know that this is an arithmetic exception, so first of all, to handle these exceptions, a programmer must know about what is the predefined class which is representing the kind of exception that is going to be generated in our program. So I know this is the class name which is representing the division by zero, that is arithmetic exception. So we have already got that here in java.lang.arithmetic exception, right? Because lang package is automatically imported into our program, we need not write an import statement. Right? So now I'm going to handle, instead of leaving that exception handling mechanism to the Java runtime system, we ourselves are going to handle this situation in our program by using the try and catch mechanism. Right. So now I'll save this file and again compile it. Let me show you. So there are no compilation errors. We run the program. So what is happening? The same hello message you'll get from the first system.out.println. This will display hello, but here an exception is generated, right? And so as a result, this system.out.println is not being executed. So now let me change this b value to say something 5, and now compile it and run it again. So you will get the value of C as 2. So that means no exception has occurred and this statement will be executed. This is .out.println. But if this value of b is 0, an exception will be generated. So look at how the exception message is displayed. Java.lang.arithmetic exception division by 0. That's it. But earlier, when we didn't use try and catch block, the Java runtime system has displayed in a detailed manner exception in thread main java.lang.arithmetic exception and division by 0 at so and so class and so method in a file called exedemo.java at line number say 7. This is how Java runtime system has displayed the description about an exception that occurred in our program. But when we use the try and catch mechanism, we are getting simply this message java.lang.arithmetic exception division by 0. We are not getting in which thread, in which line it happened, in which class it happened, in which method it happened. All this information is not given there, right? So why this is happening? Because we are directly printing the object AE, arithmetic exception object AE. Instead of using this arithmetic exception object to print using a system.out.println, there is a method which is defined in all these exception classes called print stack trace, right? Because we have automatically obtained the object for arithmetic exception class, you can use this object AE and call the method called print stack trace, right? So this is a predefined method defined in every exception class that we have. In arithmetic exception class, it will be there. In class not found exception class, it will be defined just like it is an overridden method. Okay. Uh, so you will have a super class called exception class, and for that, all these other classes are subclasses. So we'll discuss about the hierarchy of those classes in a detailed manner later. As of now, you must understand that this is a predefined method which is defined, which is a member of all the exception classes. Arithmetic exception class, array index out of bounds exception class, null pointer exception class, class not found exception class, every class, right? So you can use the object of any of those class and call this method. But now in our program, we have an object of which class arithmetic exception. So I'm using that arithmetic exception object class object AE and calling this print stack trace method. If I call this method, let us see how the output will be. You will get this exception completely java.lang.arithmetic exception division by 0 at a class called exedemo in which a main method is defined, and this is in uh, a file called exedemo.java, and the exception occurred at line number 9. So let us check. This is line number 9, right? You are able to see line number 9, right? So this is called as print stack trace, right? This entire message that you are getting here, java.lang.arithmetic exception division by 0 at so and so class and method in so and so file name at so and so line. This entire thing is called as stack trace. This is called as stack trace, right? If you want to get this stack trace message, then you have to use the print stack trace method. If you don't want, simply you can use a system.out.println like this and use the object name and system.out.println. Then you will get the message like this. Simply java.lang.arithmetic exception. What exception occurred, that will be displayed. But where it occurred, in which file it occurred, in which class it occurred, in which method it occurred, that information will not be provided. If you want to get that complete information, then you have to print the stack trace. So this is how exceptions are handled in Java programming. So any doubts regarding this one? Hello?
Sir,
Yeah, Srujan. Understood?
yeah, sir.
Fine. So if you understood this one, then we can go ahead for the next part,
Okay, sir.
right?
Yeah, yes, sir.